Okay, so here are the selected solutions for November 2020, paper 1. This is the paper that we did in class last Thursday, yesterday in fact. Okay, so we're going to work through questions 1 to 7 and then 11, 12 and 14, which will give us 44 marks, which if we got everything right will get us into that A grade category. Okay, so nth term rules first of all. Write an expression for the nth term of the following sequence. So when you're looking for an nth term rule, the first thing you do is look at the differences between the numbers. And don't know why I've written 2 there. The difference between 2 and 7 is 5. 7 and 12 is 5. 12 and 17 is 5. Basically that's telling you that what we've got there is the 5 times table, but it's been moved. Rather than going 5, 10, 15, 20, it is going up in steps of 5, but it doesn't start at 1, 5 is 5. It's been shifted. So when the number is the same, that gives you what n rule it is. So this is the 5 times table rule. And then, because it isn't 5, 10, 15, 20, we've got to work out how far it's been shifted. So the first term isn't 5, which it would be in the 5 times table, it's 3 spaces below 5. So you're looking for the difference between what it's going up in and what that first term is. So this, you've got to take 3 off it. So the nth term rule is 5n take away 3. 1 mark there for the 5n, 1 mark for the adjustment. First 4 diagrams in a sequence are shown below. Diagram 1, 2, 3, 4. Complete the following subtraction. Number of circles in diagram 17 take away the number of circles in diagram 16. Well, we don't really want to continue that pattern until we got 17 and 16, although you could if you had sufficient time. So we're looking for a relationship between the pattern number, diagram number, and how many circles we've got. So diagram 1, we've got 1 circle. Diagram 2, 3. Diagram 3, 6. Diagram 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we then look at what we get if we take diagram 2 away from diagram 1, number of circles in diagram 2 is 3, diagram 1 is 1, take them away, 2. Number of circles in diagram 3, 6, take away the number in diagram 2 and you get 3. Diagram 4, 10, take away 6, 4. So I'm looking now for a relationship between the diagram number and the number of circles, and what I'm seeing is that the difference between them corresponds to the larger diagram number. Diagram 2, take away diagram 1, 2. Diagram 3, 3, 2. 4, 4. So the number of circles in diagram 17, take away 16, will be 17. If you're given a pattern in terms of spatial things like dots or squares or whatever, matchsticks, turn them into a pattern number again. So diagram 1 has got 1, 2, 3, 4. Diagram 2 has got 6. Diagram 3, 1, 2, 3, 4, 5 has got 8. It's just like part A then. You're looking for the difference between them. It's going up in 2s, so it's a 2n rule. But the first number, which means it's basically the 2 times table, but the first number isn't 2, it's 4. So it's been shifted plus 2 spaces. So same as with part A, B1 for the 2n, 1 for the add 2. Question 2. On each Venn diagram, shade the region that represents the given set. So this is learning for you. Okay, in your notes we've done work on Venn diagram set notation back in the autumn, and this is A union B. What this means is everything in A or in B or in both. So A union B is anything that is in that region there. Okay, so you've just got to know that. This one, the dash means not in, so it's not in A. That means and is in B. So it's not in A, so it can't be in that circle, but it is in B. So you've got this sort of crescent moon shading there. So 1 mark for each of those if you've learnt them. In the Venn diagram below, set A is multiples of 3. So that big circle there, multiples of 3. Set B, multiples of 5. And C, multiples of 6. Explain why the circle representing set C is drawn inside the circle drawn to represent set A. So that's saying that multiples of 6 are also and always multiples of 3. And that's true. Anything in the 6 times table is also in the 3 times table. So multiples of 6 are always multiples of 3. So things that are in the 6 times table, 6, 12, 18, are also in the 3 times table. That explains, there's an E1 for that. Question 3. Okay, we should be getting good at these. So the first thing I ask you to do, we know that we're going to draw the graph of x squared minus 4x minus 3. First thing to do is plot the points that you're given. So we're given minus 1, 2, minus 1, 2, 0, minus 3, 1, minus 6, don't know 2, 3 minus 6, 4 minus 3, and 5, 2. It's an x squared. The x squared is positive, so we're going to expect to have a u shaped like that. And I can use that information now to guess the sort of value I should be getting for x coordinate of minus 2. So minus 2 here is going to be up here somewhere. Could be 8-ish, 7, 8-ish, maybe 9, 10-ish. So if I got a value there of minus 3, I've gone wrong because that wouldn't give me that smooth curve. And then for 2, I'd be looking for something around about minus 7 to keep that curve going. So then we've got to calculate it. So when x equals minus 2, y, so when we're breaking out that x, it becomes a bracket. So minus 2 squared minus 4 bracket minus 2, take away 3. Minus 2 squared means you're doing minus 2 times minus 2. So 2 times 2 is 4. Minus times a minus is a plus. So that's going to be 4. Here I got minus times a minus is a plus. 4 times 2 is 8. Take away 3. 4 plus 8 is 12. Take away 3 is 9. Which is the kind of place I was anticipating. So minus 2 is 9. And then when x equals 2, y will be 2 squared minus 4, 2, take away 3. So 2 squared is 4. 4 times 2 is 8. That's a negative times a positive. Signs are different, answer's negative. Take away 3. 4 take away 8 is minus 4. Take away another 3, minus 7. And that's what I was anticipating. So I've got my B1 for 9, my B1 for that. I'm confident those are right because they fit the graph. I've got my P1 for plotting the points correctly, and now my C1 is for drawing a smooth curve. Use a pencil in the exam. I'm only using a pink pen because it's nice and easy to see on the visualizer. You're going to make sure that your curve is going through the points, and your points are clearly marked. So use a cross with your sharp pencil, not like a tiny dot which when you draw a curve through you can't see. So there's your C1. Oops, lost the question. Where's that gone? Here we go. Where are we? So we got those 2 marks. Draw the line y equals 1. So y equals 1 has to go through the y coordinate 1, and the y coordinate 1 is there. So you're going to draw a horizontal line through the curve. So that's y equals 1. If you get confused, okay, it should be clear that you're wrong. This is asking for 2 values of x. So the line has to cross the curve twice. If you thought y equals 1 was that, then you can see it's only going to cross the curve once. And you already know what that value is. It's in your table. So why would they ask you to do it? Okay, so the line y equals is always horizontal. I'm going to read that one down, and I'm going to read that one down. This one reads off as minus 0.9. I think when we did it in class it was minus 0.8. Either is acceptable. They'll allow you plus or minus 0.1 from that, and this one will be 4.8. So 2 marks for reading those off your graph. Question 4, OCW. Don't write an essay, just be clear in what you're doing and consistent with your units. A sum of money is shared in the ratio of 3 to 4 to 7. The smallest share is £210. What is the total amount of money shared? So this one isn't one where they're telling you what the total is, they're giving you part of it. So what you've got to do is you've got to work out how it's being scaled up. What have I got to multiply 3 by to make 210? So you do 210 divided by 3, and the answer is 70. So that means you have to multiply each of these by 70 as well to get the gaps. So 280, 490. What is the total amount of money shared? Well, I haven't worked that out yet. In order to do that, I have to add them together. So total will be 210, 280, 490. I'm adding them, so I'm clearly showing what I'm doing. 0, 18, 9. Yeah, 4, 6, 8, and 1 is 9. So the total equals £980, and I've made sure that I've added the correct unit there. So there's 4 marks for that. There's a method and an answer for working out the multiplier and then scaling up for the other 2 parts, and then a method for adding them together and an answer for getting 980. And then your OCW is just, can somebody follow what you've done? So yes, I can see what I'm doing there. I've got to work out what that is, times it by 70. That's what I'm doing there. This is the total, and I'm working with money. So plus 2. That's all you need to do. Question 5. Find 4 different positive whole numbers so that their mean is 8, their range is 8, and their median is 8. So this is a reverse averages question. Comes up often on the numeracy paper. So we did practice this back in September, October, prior to that. If you know what the mean is, and you know how many numbers there are, then you know that the mean is the total divided by the count. And we want to find out what the total is. We want to know what these are going to add up to. The mean I know is 8. The count is 4. So I'm basically saying, right, what total must I have that if I divide it by 4, I get 8? Or if you think of it as an equation, to get the total in its own, I've got to undo a divide by 4 by timesing by 4. So the total of the 4 numbers is going to be 8 times 4, which is 32. So the 4 numbers have to add up to 32. Their median is 8, which means because we've got 4 numbers, the middle 2, halfway between the middle 2, must be 8. If there's an even amount of numbers, it's the mean of the middle pair that give you the median. So if I had 7 and 9 there, that would give me a median of 8. Now, I know these numbers have to add up to 32, and I've already got 16 there. So the remaining 2 numbers need to add to 32 minus 16, which is 16. So they need to add to 16, and the difference between the biggest and the smallest must be 8 as well, because that's the range. So 12 and 4 add up to 16, and if you take them away, you get 8. So that gives me a range of 8, and because they add up to 32, I know it's got the mean of 8. So 3 marks for that question. Question 6. So we're factorizing a quadratic, and then we're going to solve it. So if we put a 1 in front of the x squared, so we've got every part has got a number to it. The method that I taught you for this, so that it works the same even if there's a larger number there, is to multiply these two together first of all, and I get 12. I then list my factor pairs of 12, 1 and 12, 2 and 6, 3 and 4, then we'd have 4 and 3, which means we've got them all because they're the same. And then choosing my factor pair in a way that I know I can combine to make -7. The only numbers there that will combine to make -7 are 3 and 4, and that will only make -7 if they're both negative. I then rewrite my quadratic, minus 4x minus 3x plus 12. I think in class we might have written it the other way around. It doesn't make any difference. Then deal with your first pair. What's common to those two? The only thing I can take out as common is x. That would leave me x take away 4 inside the bracket. Check it by multiplying back out. X times x is x squared. X times 4 is 4x. Plus times a minus is a minus. We then move on to the second pair, and this time we know that that second bracket has to be the same as that one. So we're looking to see what I can take out which will make that bracket work. So I can take 3 out, and then what happens? I get 3 times x is 3x, 3 times 4 is 12, but if that's a plus, that would be a plus, and that would be a minus, which would be wrong. So that must be a negative. Minus 3 times x is minus 3x, 3 times 4 is 12, minus times a minus is a plus. So it's just that little bit of faff that you've got to do to get that sign there. Then you can see that this is repeated, so that's one of my brackets, and then if I take that out, I'm left with x minus 3. There's 2 marks for that. Then for the final mark, you want to solve it. So you want to work out what values of x would make that equation go to 0. For that to happen, either this content must equal 0, so we can say either x minus 4 equals 0. Well, to get the x in its own, we'd add 4 to each side to give x equals 4. Because if we put x as 4 in there, 4 take away 4 is nothing. Nothing times anything is 0. So that's one solution. Or x minus 3 must equal 0. To make that work, To get the x on its own, I'd have to add 3 to each side, so x would equal 3. So your two answers are either x equals 4 or x equals 3. That gets you the final mark. Expand and simplify. So when you're squaring, the trick, not the trick, but what you've got to recognize here is when you're squaring, you're multiplying by itself. So you're doing 5x minus 2 multiplied by 5x minus 2. Once it's written like that, you're away, because you can remember, oh, that's FOIL. That's, I've got to multiply the 5x by the 5x to get 25x squared first. Then I've got to multiply the 5x by the minus 2. That's the outside. So that's going to be 10x, positive, negative, negative. Then I've got to do the inside. 5 times 2, 10x, negative times positive, negative. And then finally, minus 2 times minus 2. 2 2's are 4. Minus times a minus is a plus. So there's 1 mark for that. But we can tidy it up further and simplify because I've got 2x terms in the middle. Only got the 1x squared term, so I can't simplify that. I'm at negative 10 and I'm going down 10 more places. Okay, I'm not multiplying or dividing, so it's minus 10, take away another 10, minus 20x plus 4. And that's as simple as that gets. Question 7. Alice works for an engineering company. A working day is chosen at random. From keeping a record over the last year, Alice knows that for this working day, the probability she travels to work by car is 0.7, and then the probability that she arrives at work before 8 is 0.4. The time of arrival is independent of how she travels to work, so it doesn't make any difference how she gets there as to what time she arrives. Using the above information, draw and fully label a complete tree diagram. So the tree diagram, you need to separate out the two events. So the first event is how she gets to work. And she either gets to work by going by car or not by car. We don't know if she doesn't travel by car, how she gets there. It's not relevant. She's either going by car or she's not. And then the second event is whether she gets there before 8 or after 8. So the chances of her going by car is 0.7. These two branches have to add up to 1 because it's one or the other, and total probability is 1. So 0.7, if that's 0.7, that must be 0.3. Before 8 is 0.4, which means that must be 0.6. And then this branch pair, you repeat down here. So there's 4 marks for that. The first mark is just for seeing the branches as they are there. The second mark is for recognizing what each branch is, so car, not car, before 8, after 8, in some unambiguous way. And then the fourth mark is for having the right probabilities. What is the probability that on a randomly chosen working day, Alice travels to work by car and arrives before 8? So how many different ways are there through the tree that satisfies travels to work by car and arrives before 8? It's just that one. There's no other way. So we're not ORing, we're not adding, we're ANDing, which in probability is multiplying. So that is going to be 0.7 times 0.4. 4 7 to 28, and 0.4 times 0.7, 2 digits after the decimal point in the question, so you need 2 digits after the decimal point in the answer. So you got 1 mark there for 0.7 times 0.4, that's your method, and 1 mark for then correctly working out what that method or what that probability is. So that's question 7. Question 8 we haven't covered. Question 9 we haven't covered. Question 10 we haven't covered. Question 11 we have. Now if you've gone back and watched more of the video clips, this type of question comes up a lot. So if you've got m to the power of 2/3, the information given to you in the index, in the power, there's a lot of information there. If there's a minus there, which there isn't in this case, it means we'd end up with 1/m. It's the reciprocal. The number on the bottom of the fraction tells you that this, in this case, it's cube root. So that's your root. So I'm looking for a cubed root 1, and there is actually only one cubed root 1. And then the number on top raises that to a power. So I'm looking here for the cubed root of m to the power of 2, which is that one. Here, another indices question. Here we're simplifying. We're multiplying and dividing these bases together, and they're all the same. They're all p. When we multiply bases that are the same, we add their powers. Yeah, if you just remember, if you've got x squared times x cubed, that means you've got x times x, which is x squared, times x times x times x, which is x cubed. You end up with x to the power of 5. So we're going to add these two, but just to mess with your head, the second number is -1/4. So we're adding 3/4 and -1/4, and then when we divide indices where the bases are the same, we subtract the power. That's going to go now for the next couple of minutes, which is going to drive us all mad. So what we're doing here is 3/4. Times means add, so we're adding the negative. Divide means subtract. So I've got 3/4. Plus or minus is a minus. So 3/4. Take away a quarter is 2/4. Take away another quarter is 1/4. So we're looking for p to the quarter. Question 12. Simplifying a fraction. This was what we were calling kiss and smile. So we combine it by multiplying those two and those two, and then at the bottom of the fraction we multiply two bases together. So 6 bracket 2x plus 1 minus 4 bracket 3x minus 5 all over 3x minus 5 multiplied by 2x plus 1. 1 mark for that.
Yeah, 8.
For pulling it all together. We never bother expanding out the bracket, so we can leave that as it is, but we can simplify the top. So the next job is to multiply out these brackets. So I got 6 times 2x, 12x. 6 times 1, 6. 4 times 3, 12x. Minus times a plus,
Yeah.
minus. 4 times 5, 20. Minus times a minus. Signs are the same. Answer is positive. And then underneath 3x minus 5, 2x plus 1. 1 mark for clearing out the bracket on the top, and then the final mark is for tidying up that top, because I can see there I got a 12x, take away 12x, gone. 6 plus 20,
Yeah, 10.
two x plus 1. So last mark for that. So that's question 12. The last one we can do is question 14. Okay, and there's 5 marks here, and we're comfortably in the grade A part of the paper. Express 0.812 recurring as a fraction. So job 1, associate a letter with it, so we let x equal 0.8121212 and so on. Then we multiply that by 10, 100, 1000, depending on what we need to do, in order to move that decimal, move that number, so that it's only got the 0.121212 after the decimal point. So if I multiply it by 10, first of all, I get 10x equals 8.121212, etc. And you can see there that if I subtract those, the decimal part won't cancel because I've got 1 take away 8. So I've got another job to do. Now if I multiply it by 100, then I'll end up with 81.2121212. So the digits still won't align. So I can't gain anything by multiplying by 100, which means I'll need to multiply by 1000. If I multiply by 1000, I get 1000x, and that will then be 812.121212. And then you can see that the decimal parts do align. So when I subtract, I get 1000 take away 10, 812 take away 8, and no decimal part. To get the x on its own, I divide by the 990. And that's it. You don't need to do any more than that. You could cancel it down, but it's not asking you to, and you may end up making a mistake. So leave it like that. Method mark for getting it to having the aligned decimal part, and some mark for your fraction. Surds we covered same time we covered indices back in January. To simplify root 72, we've got to think about 72 and is there a factor which happens to be a square number. Now if I divide 72 by 2 I get 36, so just by halving it, it gives me a square number. Square number is one you get by multiplying something by itself. So 36 is a square number because 6 sixes are 36. Now one of the rules of surds is that if you've got multiples underneath a square root, you can separate it out. So you can write that as 36 square root times 2 square root. 36 times square root of 36 is 6, which is why we're looking for it, because 6 times 6 is 36. Square root of 2 we can't simplify, it is as simple as it gets. So that's what we're looking for there. And then finally on this paper, we've got a little bit more FOIL to do. So first, 7 times 3, 21. Outer, 7 times root 5. Can't simplify that any further. Inside, 2 times 3 is 6 root 5. And minus times a plus is a minus. And then the final is 2 root 5 times root 5. And minus times a plus is a minus. Now, if surds are something that's clicked with you, you can write down the next step without bothering with that. But we'll come to that in a minute. In case you haven't, I got 21 there. I got 7 root 5 take away 6 root 5, which we treat in the same way as if it was 7x take away 6x. It's just going to be 1 root 5 or just root 5, doesn't matter. But here, when you're multiplying a root by itself, you just get the number that's inside the root, because root 5 times root 5 is root 5 times 5, that in reverse, which is the square root of 25, which is 5. So when you're multiplying a root by itself, that's just going to be minus 2 times 5. So I've got 21 take away 10 is 11 plus root 5 or 1 root 5. So you're going to have 1 mark for correctly foiling that out, expanding the bracket, and the second mark for correctly simplifying the number part. And that's it. There's nothing else on that paper that we have covered, but I'm hoping that much of what's in there now you will be getting used to seeing in these papers and being able to deal with confidently. Have a good weekend, do some maths, see you Monday.